All right, I think we'll get started. If there's any late joiners, we will address any issues afterwards. Good morning, everyone. Thank you very much for joining our next row of webinars for the GoodWe Pro Training Africa banner. For those of you who know me, and for those of you who don't, my name is Andrew Tyler. I'm the Sales and Business Development Manager for GoodWe for Sub-Saharan Africa. I hope you're all well, keeping safe, etc. I'm sure a lot of you are still based at home, as you can see. So are we, of course. But thank you very much for taking the time out of your day to join us today. This is the first of three in this series. We sort of do them in groups of three. And the newest thing is to attend to topics that we get a lot of requests for through the service team, as well as myself and my colleague David. So we, addressing the topics that would assist the customers the most. This is the first. We will be addressing the commissioning of our commercial range with our SEC1000 device. And then we also have another 2 webinars coming up. The first of which is on the 24th of August, and that is load shedding planning, what to expect. The idea behind that is to address the common issues that customers experience in the event of load shedding. We notice a massive inrush of calls and tickets during that period, so we want to try and address those to assist the customers, on site while they're there, and of course ensure that they're well equipped. And then rather the second webinar in the third in the series, but the second upcoming one is on the 31st of August, which is a sort of SEMS portal overview, but not just a general overview, a tips and tricks overview, which will look at the various ways to identify potential issues such as overloads, firmware issues, et cetera. There's a lot that the portal can do. That's our SEMS portal that a lot of customers don't know. Cool. Thank you very much, guys, again for your time. I'm going to hand over to my colleague, David Havencha. I'm sure a lot of you know him quite well already. He's our technical manager for Sub-Saharan Africa, and he'll be taking the webinar further. Thank you very much, and I hope you enjoy.
Hi, everyone. Welcome to our training this morning. I hope everyone can hear me nicely. You do hear me loud and clear, Andrew?
Yes, I do, yeah.
Okay. Just wanted to make sure. So this is going to be a much more technical overview looking into our inverters as well as the SEC device for power limiting. So I'm going to go over our inverters, the overview of the inverters, the hardware installation, the inverter commissioning, the SolidGo app, and the SEC1000 configuration. So first we have our MT inverters. So this is a picture of a slightly older one without the AC cover attached. Yeah, you can see the MPPT inputs. So this one specifically is most likely an 80 kilowatt MT. So you'll see it has 3 inputs per MPPT on each of the 4 MPPTs. We then have our Rs485 connections and then the Wi-Fi communication port for the Wi-Fi. Just a side view of the inverter as well. And you'll see on the side there, number 1 is the external fan cover. So these are external fans which are accessible externally. So for any operation and maintenance, it's a simple few screws and then you can take all the fans off. So if over many years there is a problem with a fan that needs to be replaced, they are quite easy to replace externally without any hassle. It's simple, releasing 2 screws from the top and the bottom, carefully pulling it apart and then disconnecting the fans on the connectors. At the bottom we'll see the DC switches at number 2. So that's a DC switch per 2 MPPTs. And then on the opposite side where our serial number of the device is, you'll see the grounding terminal. Here's just a look. This is slightly older pictures of the MT internal. So this is the service hatch, which you guys open to work on the device. Yeah, you can see we have our control board, which is number 1 on top. Then we have our fuse board below. So if you look at the fuses here on this device, so this device is a MT 50 kilowatt. So the 50 kilowatt only has 3 inputs on 2 of the MPPTs, as you'll see here. The other 2 MPPTs only have 2 inputs. So those ones with 2 inputs don't require fuses, so there are no fuses internally for them. Whereas the 80 kilowatt will have fuses throughout. Below the control board, you can see also the SPDs for the DC side. Number 3 as well is our AC terminal connector. This is a very old one, so the new one is much larger. As you can see from the internal on this picture, it's a much bigger, more robust connection terminal. And this is the control board, but this is a much older control board than what we have in our devices now. It looks quite a lot different. Over here on the new control boards, we have our remote disconnect. So I'll just pan through to our user manual for you as well for this. And then we have our Rs485 connections here. So this one is pointing downwards, but our Rs485 connections are pointing upwards now. So just for that, I'll show the user manual. So you'll see the Rs485 connections here and the remote disconnect terminal below. So these are just things you need to note. This is very important, the remote disconnection terminal. Always make sure that this is inserted. Very often you might find this connected in your accessory box and not installed on the inverter already. So always make sure you take that out of your accessory box and install it in the inverter with a bridge on these 2 ports here. You'll see where the top 2 screws are. That takes the bridge to make sure that your remote disconnect function is disabled. Then the MT, there are 2 versions for the MT, one with an LCD screen and one without an LCD screen. As you'll see, the one with LCD has a few LED indicators, the LCD screen with a bunch of buttons as well. And then the one without only has 4 LEDs for indication. So for most commercial applications, it's mostly ideal to get it without the LCD screen. This way, customers cannot just press buttons and change things on the device. Then we have the HT inverter. As you'll see, this is much larger than the MT series. As you'll see, from the 110 and 120 kilowatt, we'll have 12 MPPTs. As you'll see, we have DC switches here below. The DC switches, you'll see switches a multiple of the MPPTs. So each DC switch covers 3 MPPTs. As you'll note here, DC switch 7 to 9, DC switch 10 to 12. So the 3 MPPTs are isolated by each DC switch. Then we have our communications port here and our alternative communications port as well. So COM1 is for the Wi-Fi and Bluetooth. COM2 is going to be for your Rs485 bus. This is the right-hand side view of the HT inverter. So on the side, we have our AC terminal box, as well as 2 grounding insulation points, the back bracket mounting points, and the lifter, so holes for you to lift the devices. So if the devices are slightly heavy, I'll show that in the installation overview. We do have places where you can install hanger bolts to lift the device up. And then we have the other side view. you can see is the other hanger bolt, the external fan connector. So this one has 4 screws, and then you can slide out the whole fan assembly for the device. So this is for maintenance. So that's why it's always important to keep enough space on the side of this device to open this hatch to remove the external fans. And then we have our warranty void sticker for the main cover. On the HDs, we only really have the devices without LCD. So you'll see we have the 4 LEDs, power, run, COM, and fault. Now we move over to the hardware installation. I'm primarily going to be focusing on the HD for this section, since it is our new device, but it is quite similar to MT. So just general tools that you'll need on site. So first you'll open the box. In the box you'll see there is the mounting bracket, which you remove from the packaging. So this can also then be installed first before you remove the inverter from the packaging. So that's why all our mounting brackets are always on the top for ease of access. In the box, you'll find an accessory pack. So this is the accessories for the MT. It's always important to note that when you open the accessory pack, that you see that you have all your accessories there. In South Africa, we should have standard the Wi-Fi module with all of our devices, with all of the MTs, with all of the HTs. So it is very important to make sure that accessory box is kept safely and not just thrown to the side when you pull the inverter out of the box. As I said, for the MT, we have the green terminal connectors. Some of those may be in your accessory pack. Just make sure that all your accessories are kept safe one side so that none are lost. As you'll see, we include the mounting fixtures for the mounting brackets, the roll bolts, and any connectors you might need for the inverter itself. Same for the HD. For the HD, you'll see the HD comes with our new type of Wi-Fi module. It's a quick connection module, so that simply plugs in a sort of a USB interface. Please note that this USB is not a standard USB, so you can't just plug any USB into it. The Bluetooth module as well on the right-hand side of the Wi-Fi module on the page, you'll see that's our Bluetooth module. So that if you just want to do a quick commissioning of your system, you can also hot swap the Bluetooth modules between the devices. So that's not a standard Bluetooth module. You can't use any Bluetooth module on our device. You have to use our specific one. As I said, that port is not a standard USB port. It's just a USB kind of port that we're using for the connection. For our accessories, you'll see number 6 over here. That is your Rs485 connector. Just make sure you keep that safe one side, because should you need to use the Rs485, you should have that installed. So even if you're only using a single inverter at the moment, it is advisable maybe just to install that on the inverter. So if in future you do need to install a second inverter on the site and have communications between the 2 inverters, that you have that. Otherwise, you'll have to purchase it separately. Number 7 is a bit strange. That is some putty. That's special fireproof putty that we include for the HD devices. That you can put over your AC terminals. So should there be any loose connections or anything like that, that will mitigate any heat going through to any of the other components should there be a failure. So that's just a nice little extra which we include. And just for any wondering, number 10 looks a bit strange. So that is the tool to dismount the Wi-Fi module, which is included. I'm sure I don't have to go too much into this. This is just standard mounting of a bracket. In the manual, you'll see we do specify the diameter of the drill bit to be used, the depth that it needs to be drilled for the roll bolts and everything that we include. This is what I was explaining earlier. So we do have handles for lifting. So we do include flat handles on the device that you can just screw in to help easily lift it up. But you can also procure round eye hooks if you require. So if you need to lift the devices in to install them slightly higher and you need to use a winch or a crane or something like that, you do have the option of installing those eyepieces to make it easier to install the inverters and hang them up on the wall. Oh, this is just the general DC crimping. It's always important to use a proper crimping tool when crimping on the MC4 connectors to make sure that there's no loose connections. It's always important to make sure that we tighten the MC4. My apologies. My Burbl's making a lot of noise. Then we have the AC connections. So this is just a picture of, so should you be using a single core cable, we do have the option for that one can use single core cables, but we also have the option of using your multi-normal armored cables as well. So I'll just briefly show you this. So as you can see, once this has been installed, you can use your fireproof putty, which is provided by us, to cover around the AC terminals or around the entry points of the cables, just to make sure that there is no risk of fire. So even if you're using a multi-core cable and you strip it around the bottom, you can also use this putty to put in between your conductors at the bottom to make sure, should anything happen and there's a hot connection or anything like that, that it won't melt down all the way in and cause an explosion while the three cables touching each other. And as you'll see, the ground terminal is here below. Then for the HT, so in all of our user manuals, we do have specifications for the AC breakers that need to be installed for the AC input to the inverters. So it's important just to note we are using the correct size breakers so that there is no nuisance tripping issues or anything like that. So the 100 kilowatt, we recommend at 200, 110 the 225, 120 the 250. The reason we do recommend larger breakers than the nameplate rating is because of our power boost that we have with all our inverters that's able to output an extra 10%. So the 10% is quite a lot when we come to a 120 kilowatt inverter. So that's why our breakers are quite a bit oversized. Then we have our Wi-Fi module and Bluetooth module, which I mentioned earlier. So these are very simple to install. With the Bluetooth, you just plug it in, you open your phone app, which I'll show you a bit later. You do not pair to this Bluetooth device. Please note that no pairing is required. If you pair to the Bluetooth device, your app will not detect the Bluetooth device. So you don't need to pair to this device at all. You simply plug it in, open your app. The app is SolarGo, which I'll go through shortly. And then you can select your device and do the configuration. Alternatively, you can do the standard method, plug in the Wi-Fi, connect your device to the Wi-Fi, open the app and do the settings in that manner. Alternatively, you can also just install the Wi-Fi later to do the Wi-Fi connection so that you have it connected to the portal. Now we come through to the Rs485. communication connection. So on the inverter, we have this terminal plug for the IP rating. As you'll see, we do include ferrule for the ends. So it's important to push your cable through the connectors, then make your cables off. So as you'll see on this one, we're using 2 pairs. So that's an in and an out. So if we daisy chaining multiple inverters, we use 2 pairs. So that will go from one inverter to the next inverter. And then lastly, it will then go to our SEC1000. And as you'll see here, as depicted in the manual as well, we use pin 1 and 2, and then pin 3 and 4. And this plugs into the COM2. Then installing onto our loggers. So on the SEC1000 or EasyLogger Pro, the bottom of them are identical, the input ports. So there you'll see the COM1, COM2, and COM3. In the SEC1000 box or EasyLogger Pro, but for the HTs you'll use the SEC1000 and not the EasyLogger Pro in most instances. You'll see we do also include the green terminal, the 2-pin green terminal plugs. It's also important to keep those accessories one side. You might not use them all now. You can plug them all into the device, or you can keep them in your toolbox for future requirements. So should you lose a remote disconnect pin, these do work as well. Sorry about that. This I'm not going to go too in depth, so you guys can read this later when we send out the presentation to you. So this is just the general specifications for Rs485 cabling, just to ensure that you have proper communication between your devices. We know a lot of you guys are very experienced and already use Cat6 on most of your installations. But this is just a general guideline for the communication distance. So between 1 meter and 400 meters, if you have up to 32 inverters, Cat6 works perfectly fine. That's a normal Cat6 with a 0.5 millimeter conductor. Should you have more than 32, but generally on a single line with our devices, we only have 20 inverters per COM port. So that's going to be 20 inverters per communication line. 0.5 millimeter is fine. It's only when you have more than 17 inverters and you're exceeding that 800 meters that we have to increase that cable thickness to 0.75. So normally at 0.75, I think you do get some Cat6 that do have larger conductors. Otherwise, one would have to use specific Rs485 shielded cabling. Now we're going to move through to the inverter commissioning with SolarGo. So for all of you that aren't aware, most of our customers are used to using PV Master. So PV Master is our app for our storage inverters. Luckily, you'll see if you open PV Master now and you're trying to connect to a string inverter, you'll get a notice that says you should be using SolarGo for on-grid inverters. So SolarGo is our app that's specifically for our on-grid grid-tie inverters. So we should be within distance of less than 5 meters from the inverter itself and turn on the DC switch. We can open the settings on the smartphone. So this is for the standard Wi-Fi method where you connect to the solar Wi-Fi. As with all of our inverters, if you're using the Wi-Fi, it's simply connecting to solar Wi-Fi. That password, its default password is 1234567 and then you open the SolarGo app. You select your inverter from the drop-down list and you log in as installer. But if you are using the Bluetooth dongle, you can skip all 3 of the first steps. You plug in the Bluetooth dongle just make sure your phone's Bluetooth is on. Open the SolarGo app. You'll see it will scan for devices. If it doesn't see the device, you can just click use Bluetooth, and then your device will appear here. And instead of Solar Wi-Fi, it will say Solar BT and the last several digits of your serial number. So another point just to remember, I'm not going to go through the Wi-Fi connection because I'm sure all of you are very familiar with that, especially on a commercial side. If we are installing a lot of inverters, just make sure that when you install the Wi-Fi and do the Wi-Fi connection, that you can also change the default password for the access point, just for added security to make sure no one can access the inverters if you have the Wi-Fi connected. So once we open the SolarGo app, you'll see the interface is quite familiar and quite similar to our PV Master application. There you can go to view parameters and you can see all the different information, live running data of the device, as well as the firmware version of your device. And we can go to settings. So in settings, you'll see there are a lot of different looking settings, but for most commercial sites, there's very little that we need to do. The main thing we need to do is just make sure that our system time is correct on the device. So that should by default synchronize with your mobile phone that you're using. So that shouldn't be an issue. Then we just need to go to our grid connection parameters. So there's two selections here that we have to make. We have to select the safety option, which is our country code. So we will select Africa or South Africa if we're installing it in South Africa. I know SolarGo very often doesn't have South Africa. It only has Africa as a selection, but that Africa is NRS. Then based on how you're installing your inverter, you need to make sure that if you are installing a device without neutral, that you select the device without neutral. If you are installing it with neutral, make sure you select the star grid with neutral. So if you do not select this correctly, your device may not synchronize with the grid. So just make sure that this is selected. Then you'll see we also have the power factor settings, the reactive power settings, the anti-reverse settings. So this is the export power limit. So normally we won't enable the export power limit on our inverter because it's only if you are using a single inverter with a smart meter. But for most commercial installations, the smart meter just won't do because the amp rating for the CT currents are only 120 amps. So and the conductor size is very small. So that normally rules it out, and that's why we use the SEC1000. So we do not enable this anti-reverse or power limit, as it should state now, on the inverters itself, because that will be controlled by our device externally. There is one other thing that I am missing in my slide, is the communication parameters. As you'll see, we have our communication parameters. We have to go into that communication parameters and we have to select the COM address. So the communication address of our devices. So when we have our devices connected to the SEC1000, we need to make sure that our devices are numbered from 1 to 60. So it has to be from, the default you'll see is 245. Or 247 will be the default that they're on. If we do not change this, even if we only have one inverter, the SEC will not be able to issue commands to our inverter. So we need to make sure that the communication address for the Rs485 is set in the proper range. So from 1 to 60. And then we can move over to the SEC1000. So the SEC1000 you'll see here, which is our communication box. So this box is also IP rated. You can install it outside as well. It does have a locking mechanism and everything. So this is operated because normally you'll be installing this nearby your connection point, and especially on commercial sites, that is very often outside somewhere or off to the side of one building. And it's very important to install this near, as close to the connection point as possible. So for full accuracy of your CT readings, you don't want to have your CT cables really longer than 5 meters, because the longer your CT cables are, the more accuracy you lose, as well as the voltage reference point. So the input here on the device, so live 1, live 2, live 3, the further you are from where your CTs are with your voltage reference, you could have a slight voltage change between your CT readings, and that can also affect the accuracy of the readings you receive. The only reason I mention this is because we have had this in the past, where installers might install this closer to the inverter and run a 20-meter cable for the CTs, and that it doesn't work very well. I can tell you that much. It's also very important, so you'll see in the manual which connection point is for which CT, to make sure that the CT matches the phase input on this as well, because this is our voltage reference to our CT reference. So with the SEC1000, very often the devices, we might have new firmware for the devices, so it is always important to make sure our devices are up to date when installing them. You can contact our support team to get the latest firmware for these devices, or your distributor. They should also be able to assist you with this. It's very simple to update the firmware on these devices. You put the firmware on a normal USB stick, standard USB 2.0, you just put it on the root of the USB, so not in a folder, you just put it on your USB plane like that with the correct file name. You plug it into the side of this device, you switch the power off, you switch the power back on again, it will automatically update. It normally takes roughly 5 minutes. During the update, all of the LEDs will be illuminated. They'll come on solidly and remain on during the update process. As soon as the update's gone, you'll see the LEDs will go back to normal operation. You can then pull out the USB stick. Then we need to configure our SEC1000. So for configuration of our devices, we use an app called Promate. For this, I'll be showing you guys where to find the Promate app. So our Promate app is easy to get from our webpage. So as you'll see, this is GoodWe.com. Here we have our downloads section. So here you can by the choose document. You simply select software, and you'll see the first result will be the EasyLogger Pro SEC1000 Promate. So this first result is the Promate that you use for this. You can simply click download. This downloads a RAR file. So please note that this file may require a special program to actually extract the file. So when you open the RAR file, you'll see I use 7-zip, which is just a free program that one can use for any files like this. You can simply just extract this to a folder. I'm just going to drag and remove it. And then in here, we can find the Promate EXE. Sorry if it's a little bit small for you guys. Once you run the Promate EXE, we'll have this window open. And yeah, we're into Promate. So Promate works to the device via the network connection. So we'll go a bit into Promate now. So that's where you get Promate. So anyone can just simply go there and download it. We'll continue on this shortly. So for the EasyLogger Pro, on the LAN connection, we have two different types of statuses. So we have DHCP. So DHCP is when you connect it to a router and it automatically gets an IP address from that router. But in order for us to directly connect to it with a computer, we need to make sure that this device is set to static. So as default, they will all come out with DHCP. So that's the dynamic mode. On the side of this, next to that USB port, you'll see there is a reset button. So that reset button is just to change between the modes, so either between DHCP and static. So this is just in case we set a static IP address and we set the address incorrectly, then we can just reset it to get that back to the default standard IP address. So when you press this reset button, you have to press and hold it for roughly 10 seconds. When you let go of the button, you'll see the LEDs will cycle from right to left. As you'll see in the LED sequence, it'll go from right to left. You'll see they will all cycle through all the way from right to left. Then we know we are in static IP mode. So it's very important when you're doing this connection to our computers that it is in static mode. So another thing that you will have to do, which is also IT related, which I don't have here, is your computer. You'll have to set your computer also to a static IPv4. So in Promate, you'll see we've got the standard IP address. I can even just pull Promate up so we can see this nicely. So Promate, we've got the standard IP address here. So this is the default IP address of our logger on static mode. So that's the 192.168.1.200. We have to set our computers to the same range as this. So your computer's IP needs to be 192.168.1, and then the number just needs to be different than 200. So that can be 201, it can be 100, anything within network range. So as long as it's not 200, you'll be fine. So then once you plug in, you press connect. If it connects successfully, you'll see connection succeeds. We'll see the serial number of the logger and the software version of that logger as well. So as you'll see, yes, just says version 1.09. So version 1.09 is the lowest firmware for us to display the metadata on the portal. I think currently we're on version 1.13. So it's always important to make sure we are on the latest version. Then you'll see we have our COM port configuration. So in the COM port configuration, you tick the COM port that you are using and you set the amount of devices then it should be expecting on that COM port, and you press the set button. Don't worry, the set button is English. Just my slides are still in error. After setting that, we can hit the refresh button on the bottom side. You'll see refresh button. Then it will pull up a list of all of the devices connected to our logger. Next, we move over to the export enable. So in order for the meter data and everything to appear on the portal, essentially this is the part where you activate the smart meter. So by ticking this export enable, you activate the smart meter on the device. So now the smart meter is activated. We can then enter the plant capacity. So please note that this is already in kilowatt. So if it's a 50 kilowatt inverter, we can put 50 kilowatts. If it is a megawatt site, you can just put in 1,000 there. Then we have our power limit. So this is, are we allowed to export to the grid? If you're allowed to fully export to the grid, you can put your total plant capacity there. You can even use your PV capacity there as a limit. But if you're not allowed to export to the grid, you can set, you just press 0. Once you press set here, it will give you two options. So as you can see the bottom left of the screen, it says select the corresponding option. So you're going to get scan each phase or scan total of 3 phases. So these two options, what scan each phase means, scan each phase is lowest phase limiting. So it means it will limit the plant by the lowest usage. So that means total 0 export. We will not export any power to the grid. We'll only produce as much power as the lowest phase is using. And then scan total of the phases, that is our average phase limiting. So it will take an average of the 3 phases usage and produce to that average. So especially if you have net metering or anything like that, scan of 3 phases is most likely going to be the best to use on a commercial site. But please make sure that it is within your regulations. If you're not allowed to export at all, make sure you say scan each phase. But if it's net metering and they don't mind some export on one phase while usage on a different phase, just a general balancing, then you can use scan total. Then lastly, we're going to go to number 4C, which is our CT ratio. So yeah, we just have to calculate our CT ratio. We don't put the actual ratio number in here. So we take, since we always use 5 amp ratio CTs on this device, we don't use any of our GoodWe provided CTs. So CT90s or the normal GoodWe smart meter CTs, none of those CTs work on this because they are not 5 amp ratio CTs. We have to use just normal standard 5 amp current transformers. So we'll, as you can see in our example, we have a 250 to 5 CT. So we just take 250 divided by 5 and that gives us 50, which is our ratio. We can then press set. No need to press the get data. Get data is only really used if we are using a GM3000 smart meter with GoodWe CTs. So, or if we want to see what was set previously. So if we disconnect from the logger, reconnect, and we don't see anything here, we can say get data, and then that will populate the data that was previously set on the logger. Once that's set, we can confirm this. So at the bottom of your page, unfortunately, we can't see it on Promate. I cannot enable this. So yeah, at the bottom of our page, we'll get a get data button. So once this is set, the CT ratio is set, we'll see a get data button at the bottom or a refresh button at the bottom, which then gives us this nice overview. So this is the real-time data. So every time you hit refresh, it will show you a snapshot of what's happening at that exact time. So it's very important to check this when the grid, when your inverter power are off. So you can leave your inverters on, just don't have the AC to the inverter on yet. So we have the DC on our inverters on, we can confirm they're communicating well with our logger, but we do not put the AC to the inverters on yet. So as you'll see here, we have the P1, P2, P3, that's the power rating. We need to make sure that these are all negative values. So for our site, negative is usage from the grid. It is very important that we make sure that this is correct. Then next to the P1, P2, P3, we have the currents, and that's the currents which our CT is reading, and the voltage reference, which we can see. So if we take this current and the voltage and we times them, then we should get a value close to this number. If our value is widely out, it may be that our voltage reading is not coinciding with the current reading, so that we aren't getting a correct reading here. But we also just have to take into account the power factor. So the site's power factor may not be ideal. That's why if this is very close to one another, equipment shouldn't be affecting this too much. So normally we'll have a 0.9, 0.95, something like that. That's why you'll only see 95% of your calculation here as actual power. But if you're seeing less than 50%, it could be indicate an issue with your voltage reading versus your current. Thereafter, we can then switch the inverter's AC on. And if everything is correct, then the controller, it'll probably take roughly 5 to 15 minutes. Then we should start seeing our inverters start to output power. We can then also keep observing here and see the inverter's power that's producing. And then we can look at the meter power versus the inverter power, and that will give our load power. So if the inverter is running, we can also calculate the current then with the voltage. This we can see that our numbers coincide. If this is then vastly out, it could be that the site's power factor is just not very good. And the inverter's 1.0 output power factor is negatively impacting the current power factor. So that's just something you have to take into account. So site power factors it's not necessarily inverter's responsibility, but you can also adjust the inverter's power factor to try and compensate this. So once we've confirmed our inverter is working well, we now have to connect the SEC to the network. So this is normally the last step we're going to do, because once we do this, we connected it to the customer's network. So there's two ways of doing this. Ideally, static mode will always be the best to use, but it is slightly more complicated. Normally, if it is a commercial site and you are connecting to the customer's network, you'll have to find from their IT team a IP address range or IP address that you can use, as well as the gateway. So all of this information you'll have to get from the IT team that you can then insert here and set that to a static IP address. The nice thing of having it on static IP address is that you can do this connection, and then you can simply open Promate, connect to the network, and connect to your device. So that way your fixed IP will always be there. So should you need to connect to it to observe anything or make any changes on the site, it's as simple as plugging into their network, typing in that IP address, and pressing connect. Another trick I always say is take a Koki and write that fixed IP address on the inside of the cover of your ACC. So if you come to site in future, you can just see, oh, this is the IP address I need to connect to, and you can connect to it and continue. Alternatively, you can use DHCP. So if you're installing a standalone router just for this, as some sites have high network security, they prefer you just to install an external router, an external 3G router or something like that. You can also just use DHCP, because normally there's only going to be 2 or 3 devices on the network. Then you select DHCP, you unplug your computer, or you press set, unplug the LAN cable from your computer, plug it into your router, and you should see it connect successfully, and you won't have any issues. You can, under DHCP, also connect then to that router, use some sort of program to locate what the IP address is, and then connect to it via Promate as well. Another alternative to also set this to dynamic, so the DHCP. So if you don't want to set it through the interface, you can just press the reset button. So as long as you press it for less than 5 seconds, so I normally just say press and hold it for 3 seconds. You let go of that, you'll see the LED sequences go from left to right. Then we know we're in dynamic IP. So So then you can just unplug your LAN cable, plug it into the computer, and then you should see your server light goes on solidly. Another thing to mention in this, so if you are connecting to a customer's large network, normally they do have quite a bit of firewall protection. Very often this can impede the communication to our servers. If this is the case, you'll see the server LED will be blinking. That could be that the firewall is blocking that communication. If that's the case, then we'd have to get the IT of the company to open the network port for this device so that it can communicate to the server. But should you have any problems, you're more than welcome to contact support to help you with that. Then we can also check on the SEMS portal app to make sure that we are seeing all the data. So once you've created a plant on SEMS portal, I've not really gone through any plant creation. I think we can go a bit more into detail in another presentation into the SEMS portal. So once you've created your plant, especially if devices connected to the SEC1000, the commercial one, you simply have to add the SEC to this device. Then you'll see in SEMS we have our find more devices. You can click that button and it will then find all the devices that's connected to the SEC1000. And then you say add and it will add them all to the SEMS portal. So no need to add those inverters individually. So yeah, what we're checking on the SEMS portal, if we can see this production or the load curve is following the production, that could mean that either our CTs are incorrect or we haven't done our configuration correctly, because the load curve should not be following. We should be able to see, as you can see in the bottom right corner, we should be able to meter data at night where the PV is not producing, that you can see the load usage of the customer properly. And if we are exporting, we should then see that we have our loads versus our export. So if any of this doesn't look correct, then we might have to just fault find our CTs to make sure everything's correct. So it's always very important to, after you've done the installation, to check the next day or so, just to make sure that everything is displaying properly on the portal. For the CT check, which I did mention previously, we can also check it in this manner. So if we're on site, we can look at the meter. So inside the SEC, this is a GoodWe smart meter. So that is our standard three-phase meter, our GM3000. So this meter is hot swappable. So should there anything happen to the smart meter, it is the exact same meter as our normal GM3000 meter, except we have the special conversion board for the normal 5 amp ratio CTs. So yeah, we can also pay attention to the LEDs on that smart meter. So as you can see, the LED, so the main one we're really worried about is the power consumption. So if these LEDs are off, so the communication LED is off, it could mean that we have not ticked that export power limit. So we just need to make sure that that is ticked on Promate. If that's not ticked, then our communications may be off and the device may not be communicating with our logger. If it is ticked and you can confirm that and our communication light isn't lit, then it could be something else, and then you can just contact us for support, but I have not seen that. Then lastly, the power, so consumption. So when it's on, we are consuming energy from the grid. When that LED is flashing, we are exporting power. So it's very important to check that. So if our PV inverters aren't producing and that LED is flashing, that means the CTs are incorrect as well. And that is all for my presentation. So I think we can go now through the questions to see what questions have been asked. So
Thanks
we can answer them live.
very much, David. There are two questions in the Q&A box, and then there's one from a gentleman by the name of Malik in the chat box.
Okay.
I don't know if you want me to read it out or if you want to have a look at it yourself.
Yeah, I'll pull up the chat, pull it to the side so I can read it as well. So let's start by the first question. So the first questions are in the Q&A. So where is the power limit value come from? So the power limit is how much you're allowed to export. So we have a value there that's also based on your system size. So if you're allowed to fully export to the grid, like I explained, you set your full export power limit there. So the full plant capacity you set as your power limit. But if you are not allowed to export any power to the grid, you set that to 0. So that's based on the requirements for your site and what the utility company allows you. So that's for export power limitation. And then I'll read so more about the CT ratio and breaker ratings. So the CT ratio, that CT is always defined by your customer's requirements. So it's based on the incoming breaker. So even if you're installing a 50 kilowatt inverter, if your customer has a 1000 amp incomer from the utility, you'll have to use 1000 amp or larger CTs. So that's why we do not provide CTs with it, because each site is going to have a different requirement. And there's no use in providing a 1000 amp CT if the customer only has a 200 amp incomer. So it's always best to make sure that your CT is sized as closely to that for accuracy. And the breaker sizes, we just recommend the minimum breaker specifications for the inverters, so that if the inverter is outputting full power, that your breaker does not trip or nuisance trip. So that's all in the user manual. You'll find all the ratings for the breakers for the inverter itself. So then the next question from Andre. So can you use the SEC1000 with different inverters integrated on one site? Yes, you can. So we have 3 COM ports for inverters on the SEC1000. So if you're using an MT, you can put an MT on one COM port and HT on the other COM port. So we can't have 2 different ones on the same COM port, 2 different models, but we can have them on different communication ports. So the SEC1000 unfortunately cannot work with both our hybrids and our on-grid inverters. So we have the SEC1000S. So can you use an SEC1000 with a combination of 10 kilowatt ET and 60 kilowatt MT on one site, or is this SEC1000S preferred? So it does get a bit complicated if you have a very large site, unfortunately, because of the 120 amp breaker limit. For the ET, you will have to use an SEC1000S, and then for the MT, you'll have to use an SEC1000. So you'll have to have one of each for such a site. Unfortunately, they aren't compatible with one another because the communication protocols are quite different between our hybrid inverters and our on-grid inverters. So then genset integration with a third-party controller such as DIFE or Incombi. Is the SEC1000 still recommended to be part of the system? So no, when you use a third-party device, you do not require the SEC1000. Normally that third-party device will take over your power control. So then you do not require the SEC1000. What's nice with our systems is that you can still have the Wi-Fi. So if you want to still monitor your inverters, also for fault finding and general O&M and maintenance, you can connect all your inverters Wi-Fi to the customer's Wi-Fi. You can add all of those to the SEMS portal, and then you can have your third-party controller there for your control and grid monitoring and such. So from Michael, we haven't encountered an error on our plant where we connected the SEC1000 to an inverter and the inverters will be in reconnecting status. So for that, I'd recommend contacting support. They can help you with that. So it could be that address which I mentioned. So the inverter's Modbus address may be incorrect. It could also be intermittent communication. So if your Rs485 cabling is not sufficient, it could be a communication break. So they keep reconnecting. And it could also be the grid settings or the type of grid setting on the inverters on set correctly. Just make sure you've selected South Africa and everything there is correct. So Malik, regarding the breaker, it's always good to reference the user manual and not just do calculations. But what you have to take into account is the maximum. So in the manual, you'll have to look at the maximum power output of your inverter as well. So the maximum AC output is going to determine your breaker, but also depending on the cable runs, all of this kind of things. So that's why we recommend the minimum cable size, minimum breaker size on the inverters itself, and then you can see the inverter's maximum AC output in our user manual. And with all of that information, you can calculate the breaker that you require. Then from Jock, on point 4B, scan total of 3 phases. Would there be a possibility of creating imbalanced load and the customer being billed more by the utility provider? So yes, scan total of 3 phases. It all depends on the customer's load profile and everything. So and your requirements, what you're allowed to do. So if you're not allowed to export it all, generally you're going to switch it off. If a customer has 3 single phase metering points, and it's a sort of a smart meter that's going to count down regardless. So you'll be charged for any export. Very often it's not good to use this. So if all their loads are on 1 phase, you're going to be exporting on 2 phases while still using on the 3rd phase. So in that way, you might balance out your usage versus your export, but on lots of meters, that export's going to be seen as usage. So then you're going to have equal usage. So it balances itself out. So you just have to check. So that's why having a balanced site is more ideal for if you have to export power limit. If the site is reasonably balanced, you can get a lot more production with the average limiting versus lowest phase limiting. But it all depends on what you are allowed to do by your utility. So that you'll have to make sure from your utility perspective. So then a question from Malik. How can we connect export power meter? So with the SMTs, so the SMTs are slightly different devices. They are small MTs. Those have plugs. So in the user manual, you'll see that the Rs485 connection, as like the HT, has a plug. So it's simple as connecting the Rs485 on the correct port on the plug as per the user manual and plugging it into the device. So with the SMTs, you can use just the GM3000 for limiting. That will just provide limiting, so you won't get any meter data on the portal. And for that, you'll have to make sure that everything's correct just by looking at that LED on your GM3000. But if you do require load monitoring as well on the site, you'll have to use an SEC1000. So it's very similar as the HT's installation. So Michael asked where we can request the update firmware for the SEC1000. So you can contact our support, as we have shown sometimes previously. So we do have a support email address. So it's service.za@goodwe.com. You can just email that, or you can go to our support website, which is support.goodwe.com. So that's on the webpage, support.goodwe.com. I can pull that up for you if you like. So this is our support page, which is support.goodwe.com. Here you can come and sign up, where you can create tickets. So the nice thing about using this is you can create support tickets, so you can track and trace all your cases that are going on. And there's always a history of what has occurred. So also, if we send you the firmware on your ticket, then it will always remain here. So if you need to find that firmware again, you can log into the ticket where we sent that to you, and you can just simply download it again from the ticket. Unfortunately, we do not have a download section for all of our device firmwares. So then the last question, is there any requirement of setting an inverter after connecting a GM3000? So yes, as you'll see in the presentation, we have the power limit function. So the power limit function, which I skipped over for the SEC. So as you'll see, yeah, so if you're just connecting a SMT with a GM3000 in SolarGo, you set the antiverse or power limit, you enable that, and you select your power limit value. So if you have inverter with an LCD, the SMTs do have LCDs as well as an option. That can also be set on the LCD of the inverter. You're welcome. So if there's anything else, please let us know. Otherwise, we will close the presentation for now.
Yeah, just a word. Okay, David, there's one more question.
No problem. Yeah, it's anti-reverse, so it's just the translation, which is not that great. But you'll see it has changed now to power limit. So there is updated. You'll see it does say power limit. So that is your export power limit. So the amount of energy you're allowed to export to the grid. So if you're allowed, so some countries might allow you, like Germany allows you to export 70% of your power to the grid. So then you set your power limit to 70%, which means you can export 70% of the inverter's rated power to the grid. And if you select 0%, then it will not export any of the inverter's power to the grid. Okay,
Right,
you can take the floor. If anything else pops up, we can answer once you're done.
Awesome. Thanks very much, David, for that presentation. Again, guys, these type of topics are very much focused on the type of questions that we get. So very hard-hitting focused topics, not on overall who GoodWe is and things like that, but more rather touching on the information that you guys need. So if there are any other suggestions for webinars, etc., please send them through. You know, we're always interested to hear what our customers like to see and the types of topics we should cover. Just one thing to note, I guess in closing on the commissioning of the SEC1000 is we often get customers who call us, you know, when they're on site struggling to commission this device. If you guys are planning to do a SEC1000 commissioning with our commercial inverters, give us a heads up, you know, give us 2 or 3 days beforehand so that we can set something up with you and go over any questions or queries you guys might have. At least then you'd feel a bit more comfortable before going to site and feeling overwhelmed by the fact that it's not, you know, working the way you expected it. It really does help. Our service team is there to support as well in the event that you are struggling. Otherwise, you can also plan ahead to, get one of us on a call in advance, set up for the time that you expect to commission. I know it doesn't always work out that way, but it is quite nice to be able to assist, especially with the first one. But yeah, thank you very much. Again, just a reminder on the two remaining upcoming webinars, 24th of August for the load shedding solutions and tips and tricks, and then the 31st of August for our SEMS portal tips and tricks. We look forward to seeing you guys there. Please do reach out. A lot of you have our emails, etc. Mine is andrew.tyler@goodwe.com in case you want to reach out to me. But thank you very much for your time. This recording, as well as David's presentation, will be shared. We will most likely upload the link to our YouTube channel so that it can be viewed, over and over again in the event that you have an upcoming commercial installation. Thank you very much, guys, and I wish you a lovely week further.